Well, good afternoon. It is section 6-2, ratio tables. What I want you to do is go ahead and hit pause and copy this down. So go ahead and take a few minutes to do that. Well, ratio tables, again, as we talked about with ratios on the previous lesson, is dealing again with comparing two different situations. And that's the same thing you're going to be doing here. A ratio table is simply just a table used to find a pattern of ratios. So here is our table, and it's talking about cans of concentrate to cans of water, and we would probably be talking about juice, I'm assuming. So 1 can of concentrate to 3 cans of water. It could be soup. I know, like the Campbell soup, you're always adding so much water to every can of soup and so forth. Same type of situation. If you have 2 cans, then it would be 6 cans of water. If you have 3 cans of concentrate, then it would be 9. Okay, that is again finding that pattern. So it's counting by 3s. This is counting by 1s. Equivalent ratios are when you express the same relationship between two quantities. Okay, so equivalent ratios obviously meaning that they're the same or equal to one another, and we'll talk about that in the next couple of slides. Tongue twisted today. And if you want to look at equivalent ratios, that is each one of these ratios, 1 to 3, 2 to 6, and 3 to 9. Those are all equivalent ratios. In fact, if you look at them as fractions, you can see that 1/3 is equal to 2/6, and 1/3 is also equal to 3/9. So those are some ways to look at that. Scaling, which is multiplying or dividing two related quantities by the same number. So you can scale back or you could scale forward. Kind of like looking at my 2/6, scaling back would be to 1/3, scaling forward would be 3 to the 9. Division is for making smaller numbers, and multiplication is for making larger numbers. Okay, so let's keep this in mind as we get through to a couple more slides. So our first example, I'm going to let you hit pause and copy this down first so that you have this in your notes. It says a patient receives 1 liter of IV fluids for every 8 hours. At that rate, use the ratio table to find how many hours it will take to receive 4 liters of IV fluids. Okay, so if it takes 1 liter per 8 hours, then we're going to go to 2 hours, and the next, and you're basically doubling that, counting by 1s. If this is the case, we're going to count by 8s. Those are the multiples of 8. So 8, and then we'll go to 16, which again, if we look at our ratio, 2 to 16, it is equivalent to 1/8 by reducing it. Then we'll try 3, and the next multiple of 16 would be 24, and the next one would be 32, and then 5 and 4, which again, as you look ahead, you can see you're counting, filling this in, and filling this in, making certain that it still is in line. And 8 on to 32 would give me 40. So we know that our pattern is consistent. And again, we're looking for the question that says how long it will take, or how many hours it will take to receive 4 liters of IV fluid. That is our 4 liters. And so how many hours would that be? 32 hours. Okay, that's using this chart. Okay, these are a lot of these deal with and can relate to a lot of our problem-solving type activities as well. And that was one of our strategies that we used with our problem-solving activities already this year, was making a chart and looking for patterns. And this is another great example of doing that. So let's look at our next problem. I'm going to let you go ahead and hit pause, copy this down first, and then solve it. Alright, so it says, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Use the ratio table to find the amount of sugar needed for 4 cups of cranberries. So again, they put the 4 cups on the chart for the cranberries. So if we're getting bigger, we would multiply. In this case, our numbers are getting smaller. Okay, so if we're getting smaller, we're going to need to be dividing to get that. Okay, so if we're going from 16 to 4, and again we're trying to find this ratio of 16 cups of cranberries, you can do it a couple different ways. One, we can skip right to this and say, well, how did 16 become 4? Well, 16 became 4 by dividing it by 4. So divide this number by 4 and you're going to get 3. Okay? So that's, again, finding that equivalent ratio if you so choose. The next way of doing this would be saying, well, let's divide this by 2, and you could have 8. And then dividing this 2 by 2 is 6. So you can see the pattern of going from 12 divided by 2 and you get 6, divide that by 2 and you get 3. Same thing for this, dividing them by 2 to get that number. So if we had to and we were trying to find what it would be for 2 cups of cranberries, then you'd be dividing this by 2 to get 1.5 or 1.5. Okay, so there's lots of different ways of going about trying to solve this, and you can see that some of our rates or ratios may not end up being whole numbers either. They could be fractions at times, but they have to be consistent. We have to find that pattern. But again, if you didn't fill in these or didn't know what to put in place of these areas, again, another way of doing that is by simply saying, well, how did 16 become that 4? And since it's getting smaller, you are dividing, and we divided it by 4, so divide this by 4 to get our 3. Okay, so the answer to this again is 3. So let's look at our next one. Go ahead and hit pause and solve this. Now some of you might be having some difficulty because you're trying to figure out how you're going to get 10 into the 15. And again, as the note says up here, scale back if the numbers are not multiples, meaning they're not compatible. Because the next multiple of 10 is 20. So you're thinking to yourself, well, how can I find that? That doesn't make sense to me, being able to do that. Another way of doing so would simply by scaling back. So let's scale back to a number that would give me that still would be a 10 in part of its multiples. For example, if we scale back to 5, okay, it's half of 10. Half of 4 would be 2. Now, does 5 go into 15? Yeah, it does. Okay, so when we start to look at this and you're trying to find those patterns, now there's some extra boxes in here, because you got to remember when you're trying to set this up, you don't know how many boxes you're going to create for this table. You're the one that's making this chart. Okay, it isn't always necessarily going to be given to you. So that's why we put some extra boxes in here, not necessarily to confuse you, but to help you realize that you're just plugging some numbers in and trying to make them all work together. So they gave you 10, so if we scale back and say, well, 5, and you say, well, now we're going to count by 5s. So we've got 5, 10, now it's 15. So then it's 2, 4, and now it's going to be 6. Okay, so cans of corn on sale for 10 for $4. Use the ratio table to find the cost of 15 cans. Now you can see the pattern from 10 to 15, or excuse me, from 5, 10, and then 15, and now it's 2, 4, 6. and you can see that pattern. This one is doubling it, or doing, sorry, multiples of 4, or I said that wrong again, multiples of 2 and multiples of 5 to find that equivalency of making those ratios equivalent. Okay, and you're going to eventually find that tomorrow we're going to be able to make sure that these ratios are equal by cross multiplying, and 10 times 6 is 60, to where 4 times 15 is also 60. Therefore, we do know that they are equivalent. Okay, so again, this was a tough one. We like to throw these in here because you will have those situations to where there won't always be multiples of them. So that's what we mean by scaling back, or maybe even having to scale forward a bit to be able to find those answers. Okay, in this case, we scaled back by just giving me a number that might help that be more compatible with 15, and you can see we tried 5 and it ends up creating that. And sometimes it is a guess and check at times. Okay, so please go ahead and take note of this, and you have questions, we're certainly going to talk further about it tomorrow. So have a great evening, and we'll see you tomorrow.